Hello, everyone. Welcome to a webinar on how to prepare your warehouse racks for an OSHA inspection. I'm Dan Biter, Technical Director at Damotech, a company on a mission to safeguard pallet racking systems across North America. I've been in the business of assessing rack damages for over 20 years. I've basically seen it all in terms of rack damages in warehouse. Now, a few years ago, I became also an instructor for OSHA. I help OSHA inspectors prepare for rack safety audits. Today's subject is how to prepare your warehouse for OSHA inspection visits to improve safety and avoid fines. Webinar should last about 30 to 45 minutes with maybe a 15-minute period at the end to answer any questions. So what are we going to learn about today? Well, we're going to learn about OSHA and its purpose, the different standards and specifications that cover rack design and safety. We're going to look at the racks themselves, their parts, and how they can accumulate loads. What to look for in terms of issues or damages, and setting priority levels. Creating your own inspection protocol and understanding how to set those. So, from small damages to rack collapse. My observation after years of visiting warehouses is that people do not always know what to do or who to call to ensure the safety of their pallet racks. Employers are responsible for providing a safe workplace for all workers covered in the OSHA Act. It's not just about not getting in trouble with OSHA. It's about the safety of your workers. OSHA standards are meant to avoid trouble from happening. You simply do not want to be held responsible for any collapse. So what is OSHA and its mission? First and foremost, OSHA cares about safety. The US Congress created the agency under the Occupational Safety and Health Act. As a matter of fact, President Nixon signed it into law back in December of 1970. OSHA is a federal agency, part of the United States Department of Labor. So OSHA is mandated to establish and enforce safety standards, track injuries and illnesses, requires safety training wherever necessary, and conducts inspections and investigates complaints. OSHA inspectors, however, rarely give advance notice of their visits, which may be completely unsolicited. Workers, on the other hand, may also request an inspection. If there is no union and no safety committee with a worker representative, OSHA only has to inform management of their arrival. So how has OSHA made a difference on worker safeties? Well, proof is actually in the pudding. From 10.9 to 2.7 incidences per 100 workers in the 50 years since it has existed. Worker deaths in America are down from about 38 worker deaths a day in 1970 to 13 a day in 2020, even though the workforce has almost tripled from 56 million to over 130 million workers. So what specification does OSHA work under? It's actually called ANSI MH16.1. This specification concerns the design, testing, and utilization of industrial steel storage racks. Racks such as pushback, pallet flow, case flow, pick modules, and rack-supported work platform. It does not apply to other types of racks such as drive-in or drive-through racks, cantilever racks, portable racks, or to racks made of material other than steel. These are covered under other ANSI specifications. Keep in mind, the code has to be renewed every 10 years as part of the ANSI approval process. So let's begin by first understanding racks. Racks are designed to support weight in the form of the pallets that are located on the beams. This causes load stress. Load stress that begins from the top and accumulates its way down the bottom, mostly through the columns, that carries a minimum of 95% of all of the load weight. However, the load weight or load stress can also be distributed through the diagonal braces to an amount of 3 to 5%. This results in creating the most critical part of your rack to be the base of your rack. This is where all of the load weight actually accumulates and makes that part of the rack the most vulnerable. But this is only half of the equation. The other half of the equation is actually the forklift. If we take a look at a standard sit-down counterbalance machine weighing approximately 6,000 pounds, moving slowly at 1 to 2 miles an hour, it creates a force of roughly 1/3 of its overall weight, which in this case, 2,000 pounds of impact energy that gets transferred directly onto the rack. Now, of course, the faster the machine is moving, or the more weight that it actually carries, the greater amount of energy is actually transferred on that impact. And keep in mind, frame columns are not designed to withstand any amount of impacts. They're strictly designed to support weight. So, knowing that, how do I prepare my racks for an OSHA visit? Well, what we're going to cover is the following. How to identify the damage and issues on your racks. Next, we need to look at how to assess the priority level of the damaged racks and issues identified. It'd be good to have a way to communicate the situation clearly so that everybody that is involved in the process understands what these issues and what these damages are and where they are located. And finally, we need to create a plan on how to address these issues or damages and determine best way to move forward. So first, let's take a quick tour of a racking system. Here's what you need to look for. Upright columns. Upright columns are the components of actually the upright itself, the front and the back column. We look at beams. Beams are there to support the pallets between the front and the back beams. Safety bars. They prevent pallets from falling through the beams and are attached to the front and the back beams. So when inspecting your racks, this is what an OSHA inspector will look at. Uprights. They look for frontal and lateral deflections, plumbness, twisting, rusting, any kinks or dents that could be identified as a potential damage to your upright. When it comes to the beams, they look at deflections. They look at the connecting points, the safety pins, are they present? Safety bars, again, they look at things as, are they present? Are they secured? Do they show any signs of damage? Next, we look at braces, be it horizontal or diagonal, and you also need to take a close look at the bottom of the columns for the foot plates and anchors. When doing your inspections, make sure to pay attention to, in case of the braces, are there deflections to them? Are they actually present? Have they been torn off? Are the welds damaged? When looking at the anchors, keep in mind that anchoring the pallet rack to the ground is recommended to ensure its stability and resistance in case of an impact. So you should be looking for things such as, are the anchors even present? Have they been sheared off? Have they been bent under an impact? Are the nuts present? Are they nice and tight, or are they loose? At both extremities of any rack system, the racks should be taller. This is done as to prevent packages from falling over onto a pedestrian pathway. Now, having said that, this is not necessarily in the code, but it is recommended by the Rack Manufacturer Institute, otherwise known as RMI. It is especially important to keep in mind if you are in a high seismic zone. So, some of the other things that we look at: pallet positioning and pallet conditions. Are the pallets properly positioned on beams? Are the pallets themselves in good shape, good condition? Safety pins. These are small, but mandatory safety devices used to prevent beams from dislodging. Wire mesh decks. Wire mesh decks are basically an extension of safety bars, designed to help prevent pallets, products, and debris from falling between beams. Row spacers. They play a very important role as back-to-back racks attached to one another gains strength when one of the racks gets impacted. These are all very important components of a racking system. Now that we've looked a bit at how the racking system works, what should you look for in terms of frontal and lateral damages, as well as brace deformation? Let me show you what we call the 1, 2, 3 rule, which will help you determine in what priority damages should be addressed before an OSHA inspector shows up. This rule allows you to evaluate the degree of deformation on upright elements. 1, 2, 3 refers to the 3 damage tolerances. So 1/4, 2/4, and 3/4 of an inch. The 1, 2, 3 rule can be helpful for you to assess rack damage in your warehouse. Not only is it easy to remember, but it will make your inspection more concise. So let's start with the easiest, a frontal deformation. If your damage is greater than 1/4 of an inch, as we can see from this image here, you need to start taking some actions here, whether it's to replace or to repair the damaged rack. Lateral deflection. If the damage is greater than 2/4 or 1/2 an inch, then you need to start looking at taking some actions as well, as this image right here would highly suggest. And for a brace, if the damage is greater than 3/4 of an inch, either a brace being a horizontal or a diagonal, you need to address this situation. If you need help in navigating rack damage assessment, for example, what to look for, various resources are at your disposal. You can download the assessment pocket guide. It provides clear guidelines to help you determine what to address when assessing an engineer's rack system's condition. You can also order a free safety poster and use it in your employees' break room, for example, to educate them on what to look for in terms of damages. So we wanted to present to you some high or unload damages, as a matter of fact. Here we have even an example of some custom rack repair. The point of showing this isn't really to laugh about it, but to emphasize the importance of proper inspections. It's important to remember that even though rack welding can be considered an acceptable approach according to code, it's not recommended. A proper weld can be very difficult to achieve, and it can impact the metal and the rack's load capacity. If a damaged rack is not repaired correctly, then this damage can become a greater issue over a period of time. Taking a quick look on the other end of the scale for low priority issues. Low priorities doesn't mean that you should forget about them. You should check back periodically to see if their conditions have evolved or if other damages have occurred. Remember, issues or damage can worsen, So several low priorities can easily and quickly become high priority. If in doubt, you always have the option to bring in an expert. Next, we talk about nomenclature. How do we communicate the information that we have identified in our inspection? Well, the nomenclature that we like to use is we break down a rack down to its components. A rack or an upright is composed of two columns, front column being C1, back leg column being C2. Both of these columns are attached together via braces, both horizontal and diagonal. Starting at the base, the first horizontal, we call it H1. First diagonal, we call it D1. Next horizontal, H2, next diagonal, D2, and it continues like that, H3, D3, H4, D4, so on and so forth, depending on the overall height of the rack. C1 also representing the front of the rack, whereas C2 represents the back. And when you want to talk about and refer to anchors, A1 represents any mention of anchors on the front column, while A2 represents the same, but on the back leg column. To develop an inspection protocol, you must first address a few very important points. First of all, frequency. There's actually no clear guidelines about how often your racks needs to get inspected. There is a best practice to do it once yearly by a third party and do your own assessments on a periodical basis, be it weekly, monthly, quarterly, based on your warehouse's activities. Next, who should inspect? Who can do it? Who is qualified to do it? Well, when your employees are trained on recognizing damage, they should be okay doing the routine assessment. Again, when in doubt, we fall back to calling an expert. Speaking of that expert, bring in an expert once a year to give you a baseline, thorough inspection of your facility. What to report? Well, we'll get into more detail on the next upcoming slides, but you need a system, be it on paper, Excel, or dedicated software to keep track of issues and how they are being addressed. Finally, we need to keep records. If OSHA asks for any documentations, you need to be able to provide them. Again, we're going to cover this in a slide that's coming up. So to help conduct your own rack damage inspections, you could use a rack inspection checklist. Here's an example of a checklist which can be downloaded for free on our website, something rather easy. We've simplified it as much as possible. There's a section to write the dates, the location where you performed the inspection, the inspector's name, sheet number, as well as the frequency, again, being weekly, monthly, or quarterly. In this inspection sheet, each row represents an individual damage or issue that needs to be addressed. So let's look at how you should fill out this inspection sheet. The first thing you'll want to fill out is the location of the issue where it's been identified. You need to have a proper way of identifying each upright in your warehouse. This allows other people looking at this sheet to easily find this damage. If you already have a numbering system, you can use that. If your racks don't have any numbering, you could use a simple approach where you start on the leftmost asset of your system and move towards the right. Then we want to fill in the corresponding cells that represents the damaged component. Along the top, you have all of the options for different elements that an issue can be on. For example, columns, braces, beams, etc. But you should just not add a check mark or an X. For example, you need to know if it's a front damage or a back damage. So in this instance, the upright column is indicated as 1, representing C1, the front column. Next, you need to fill in the priority of that damage. U for unload, H for high, M for moderate, and L for low. In this example, U is clearly what is indicated, what is required to be shown here. Finally, there is a section for observations and any extra notes that you may feel are required and necessary to inform people as they come and follow up on these damages and issues that you have actually identified. Moving forward, quite simply, we're seeing here an example of a damaged brace. It is the second damaged brace, D2, and it is considered low in priority. Next example, and this is an interesting one. At this location, the fourth beam level is actually severely damaged. This is an unload situation. And so these pallets that are here should be removed until a new beam can be installed. Specifically here in your notes section, you got unload and cordon off. So these are instructions moving forward for the people to handle this situation properly. It is good practice to keep a history of your inspections in a binder. This way, if OSHA asks for any documentation, you will be able to provide them right away. To better manage the maintenance of your rack assets and track your progress, you could use an inspection and management software. It can help improve safety in your warehouse by ensuring that the inspections are completed correctly. It allows you to access your data in real time, simplifying the process of tracking issues within your own warehouse. If you would like to explore our platform, scan the QR code or visit our website. You can create a demo account or even request a personalized demo with a rack safety specialist. But remember that no matter how you do it, make sure to keep records of your inspections or assessments. The OSHA inspectors will likely be asking for them. As part of keeping records, there's other documents that are also required. Most important is what's known as LARCs, which is an acronym for Load Application and Rack Configuration Drawings. They show all the configurations and capacities of all of your racks. You should not operate your racks for which you don't have any drawings or capacities. Whenever you change beam levels, remove or add beams, you should have the corresponding LARCs because doing things changes the capacities. You also want to make sure that your capacities are visible to everyone through either plaques or labels. It's actually in the code, so this is a must. Now, let's talk really quickly about how to address these issues. First, to avoid any injuries, remember to cordon off areas around the racks that needs to be unloaded, since complete unloading of the racks is necessary before actually dismantling them. Also consider if it's necessary to replace a whole upright, or could you simply repair the damaged brace or column? And taking a step further, what about actual rack protection solutions? Before replacing a damaged column or brace, let's consider rack repair solutions. For example, taking a look at this picture of a before damage and this picture of an after damage that was highly impacted, the damage was somewhat below 24 inches. And in this situation, a heavy-duty repair kit taller than the damage was recommended. This kit is often installed at the end of aisles because racks in those areas are more prone to being hit by forklifts. And so having such a strong element right there guarantees that you will not face the same situation twice. If you want to minimize damage in your warehouse, you should install protection first. For example, it's important to protect your pallet rack uprights because they are the most vulnerable to impact. A post guard can prevent damage to your warehouse storage systems. it will also minimize maintenance costs over time, as well as extend the life of your racks. But there is more than racks in your warehouses. Guardrails can help you protect your workers and pathways. Your building columns should also be protected, being the backbone of your building's structural integrity. They cost a lot to repair and can have dramatic consequences if severely damaged. A column protector will protect them from impacts by forklifts or any other machineries found in your facility. If you're not sure where to start and would like some more information, you can scan our QR code or visit our website to access our download section where you will find various documents. Let me remind you of the steps that you can follow to prepare your warehouse for an OSHA visit. First, identify issues and damages on your racking system. Don't forget the 1, 2, 3 rule. Assess the priority levels of these issues, whether it's low, moderate, high, or if you must unload right away. Communicate the situation clearly and keep track of it by using different available tools like an inspection checklist, a binder, or even a rack inspection management software. Finally, create a plan to address the issues identified in the inspections moving forward. As you can see, the best time to plan for an OSHA inspection is before it actually happens. Your workplace should always follow OSHA regulations and standards. If you are not sure where to start and need help navigating warehouse safety, please contact us. No matter the questions, our experts are ready to listen and share their knowledge so that you can succeed in achieving your safety goals. We can help your warehouse operate more efficiently and be a safer place, whether it be with conformity inspections, rack safety products, or even employee training. You can write to us or visit us at our website at damotech.com to find immediate answers to your most pressing questions. If you'd like safety tips, you can read our knowledge base or check out our blog section. Wanted to thank you real quick for taking part of this short webinar. I'm hoping that this information has been helpful to you. And now answer a few questions that may have been left unanswered so far.
Hi, Dan. So
Hey.
a couple questions have been answered in the Q&A. So if people would like to go to see the answers, they're available in the Q&A section. I also have a couple more questions to ask you directly.
Okay.
So the first one, how often do OSHA inspections happen?
Now that's a really good question. OSHA's inspection patterns are actually very random. There's no schedule that says they're going to visit any sections whatsoever or any geographical area whatsoever. And it also depends on how many written requests that they have, because this will also occupy their time. So there's no definite answer to that. It's very random.
So I have a second one.
Yes.
Instead of safety pins, can bolts and nuts be used?
Of course. Safety pins are the standards that is used in the industry, but nuts and bolts are actually a stronger fix and attachment for the beams directly onto the columns, and I would very much recommend them.
If I may add, Dan. So
Yes, please.
Charles speaking here. In certain locations, like in Ontario, for example, if you do change safety pins for bolts, you still need to have a PSR executed on them because any change to a rack system requires an expert to validate the change. And so it's not the same everywhere, but in particular in Ontario, you're required to do so.
This is for those locations that are in Ontario, Canada. We have a particular system of verifying any changes to the racks called the PSR. Not applicable necessarily to the US or many other provinces for that matter. Would there be another question, Natasha?
Yes, there is. Is wire decking mesh required on all levels or just on the bottom level? And is there a standard that's applicable in Canada?
Well, that's actually a very good question. And I think Charles would be in a better position to answer that properly.
Yeah, so I did answer, I did write the answer in the questions there. So only the bottom level of racks where people will either drive or walk under will require a wire mesh. And that is to prevent, objects, even products from falling through onto the people walking under. But it's not necessarily code. There's a slight difference between a requirement and the codes. They tend to be very careful about which words they use. And so sometimes it's a recommendation, but it's not required. You have to be really careful about that. But when you're talking safety, is it a good safety device? Yes, of course. It's a bit like having safety bars into your rack. Is it required? No. Is it a very good safety device? Yes.
So let me ask you another question. Should all the rack damages be repaired right away?
That's an interesting question and a very loaded one. First of all, after an inspection, the damages should be prioritized from low, high, moderate, high to even unloads. The unloads and the highs are the ones that should be addressed first and foremost. Let's get rid of those issues, and then let's look at what comes next, moderates and lows. Some of them can wait a little bit, especially the lows. They don't have to be necessarily repaired immediately, but they must be, they must have an eye on them at all times to ensure that they don't get worse and become a low going to a moderate or a high or even an unload situation. So I'm not sure if that answers the question properly, but you start with the highs and the unloads and you work your way through that first.
And basically, think about your insurance company. They come in and they see that you have a system, you're rating things. Of course, you can't address everything as it happens. There's always some delay. So somebody might hit it really hard and then see that it's a really bad damage. Those that we qualify unloads, well, you stop working and you address it right away, right? You don't necessarily need to replace and repair right away, but you need to block off these aisles that are affected. So if an upright is really badly damaged, on either side of that upright, you remove all of the material and you make sure that the neighboring uprights are not leaning. They're kind of out of plumb because of that impact. So we need to check on that. You need also to check the impact of if you damage a column, an upright, the beams might be pulling on the neighboring columns and damaging the connection holes. So that might affect the capacity of the neighboring uprights as well.
All right, thank you for that.
So I have another question. What about diagonal braces? Do they have to align in the same direction?
Align in the same direction as the original design?
Yes.
So racks are designed by rack manufacturers engineering group to be able to handle low stress in a very specific manner. Diagonal braces sometimes are zigzag where they go back and forth left to right, and sometimes they always go down in the same direction. It entirely depends on the design from the engineers, their intent of how they want it to work.
And just to mention this, do not replace an upright that had a Z pattern bracing with something else that you think looks or feels the same, because you're exposing yourself. You might have weakened the system, or even if you put a stronger upright, it might have adverse effects that were not initially calculated. So that's part of the reason why in Ontario they have that pre-start safety review, just to make sure that nobody is playing around with these systems that basically I tell it in different situations where I say, imagine that these racks, you know, if it's 2,500 pounds per pallet, it's like having a Ford F-150 at every beam level. And you walk down the aisle, how safe do you feel now that you see these trucks hanging above your head? So these are structures that are really well optimized, and we cannot mess with them that much. Because if there's one that collapses, you could have a domino effect, and then it's totally out of control.
Is there a recommended height for protective guards around the bases of the vertical columns in a rack?
That's actually an interesting question. Statistically speaking, most damages occur within the first 24 inch. These are just numbers that are out there in the industry representing where most damages occur within the first 24 inch. So that would be our recommendation. Post protectors or any other protection of any sort that acts to protect the upright column itself would be the most effective if it actually covers that first 24 inch in height.
So next question, do safety bars need to be pinned into the rack, like with a screw?
Safety bars should definitely be screwed into from both the front as well as the back beam in order to ensure that they don't move around and become less effective because their positioning is not where it needs to be any longer.
Yeah, and the way we interpret the code on this is that the code does not force you to have safety bars, but if you do, they must be attached to the beams. And because if they move around, it gives people, the operators, a false sense of security that can create a dangerous situation. So they have to stay in place and be, you have to be able to count on them.
Thank you for that. So next question, is homemade racking acceptable? And could an inspector pass the racking to meet CSA standards?
Yeah, you give me plans for a new structure, we can calculate such a structure. But when we're talking about something that was homemade, we have no clue how the welds were made. Was it in control? There's no drawing, there's no engineering stamp on it. No. We cannot certify this. And there's no real process except to ask an engineer to stamp it. So an engineer, usually you'll have a structural engineer that will consider a whole lot of things, that will probably ask you to talk with the guy who did the welds, if a guy it is, and try and figure out the capacity. But there's great costs that come with this.
So next question, does racking under the 3:1 height to depth ratio need to be anchored to the floor?
Charles, you want to handle this one?
So it was 3:1. So the code says you got to start worrying about overturning of the racks if it's a ratio of 6:1. When you're very low, like 3:1, anchoring is important, especially for impact. So as you know, Damotech, we deal a lot in rack repairs. And what we've seen is very convincing that, yeah, you have to anchor the rack, if only to help prevent a full collapse of the upright. Imagine that you slightly bump a rack, and there's plenty of videos out there where we don't really understand what happens in the crash, the collapse, but we can see it was a slight bump. It was not that big. So sometimes you wonder, were the racks really well anchored? What exactly happened? Well, for sure, like Dan showed, you know, a 6,000-pound forklift carrying a 2,500-pound pallet or even 3,000-pound pallet will always win against an upright leg. They're very flimsy. Like I said, these are very much optimized structure, to handle vertical load and in seismic loads, some horizontal loads, but they are not designed for impact ever. The cost would be like tremendous, the initial cost. Now, even when you put protection like guards and such things, they will protect against bumps and sometimes rather hefty impact, but not full speed impact. The forklift will always win. So back to that question, the anchoring when you're above a ratio of 6:1 is really to make sure that there's no overturning of the rack. And when it's 3:1, I strongly recommend to still anchor it.
I'll ask the next question. Where can we find out if the ANSI codes have been renewed within 10 years?
Yes, so the latest code, the American code, is dated 2021. And there will be a review coming soon in 2022 because of changes to the American Society of Civil Engineering calculation of seismic forces. We don't expect it to be a major change, but yeah, so the latest one is 2021. And the way to find out, you can go on the RMI website. So RMI, we are a member of RMI, Damotech. It is the Rack Manufacturer Institute, and it's they are part of the MHI nonprofit, so Material Handling Institute. So you just type MHI and RMI on Google, and you'll end up at the right place. And they are the ones developing the code. ANSI is the one that supervises the whole process of writing the code. And the RMI is the one that publishes it and sells it on the web.
So next question, should the anchors have all 4 bolts in place, or is it okay with just 2 or 3?
So we're talking about having an anchor per column, one in the front and one in the back, or should both anchors be positioned on each of the columns? Problem with the damages, there's 2 types of damages that ever occur on the rack. There's what we call a sudden impact that just knocks out your rack, or accumulated impacts. Those accumulated impacts are the greatest cause of damage found in any warehouse facilities. So if you can somehow avoid those accumulated impacts from occurring, you are actually extending the life of your racks. And by putting 2 anchors down per column, you're avoiding a twisting effect. Whenever a pallet or a forklift would impact your column on from the side. And so if you can do that, combine that with a post protector, you're actually extending the life of your rack. So trying to keep the answer as short as possible, filling out both holes would be the best answer, best way to go.
Yes, and the answer to that is somewhat misunderstood very often. All rack systems, and Dan mentioned it, all rack systems should have a set of drawings that are stamped by an engineer. So again, these are highly optimized structures and they are rather fragile. So this is serious engineering. So the anchoring is specified in these drawings from the engineer. So the engineer will say only 1 anchor is required, or it will say we recommend 2, but only 1 is required. It depends. Like I said, they don't really look into the damage of the rack or the impacts. But like Dan said, we prefer recommending 2 anchors to prevent the twisting of the column. That is quite helpful in the long run.
So how do you figure out the capacity weight of your racks?
Oh, I'm definitely letting Charles answer that one.
Yes. So when you're dealing with used racks and you don't have any trace of the documentation for that rack, There is many ways you could try and identify who is the manufacturer and try to contact the manufacturer. What we see out there is there's many warehouses that have been bought in different sections. They have different manufacturers, and therefore they would have to contact 5 or 6 different manufacturers, and 3 of those have disappeared. They're not in business anymore. So what we do when we go in with our engineering mandates, we measure the whole thing. It's crazy like that. We go in, we measure the shape of the columns. We have a database of about 120 or 140 columns. It's growing every year, where we have the mechanical properties, and we really start from that. And we determine the size of the braces, the dimensions of the welds, the beams themselves. And then depending on where you're at, we determine all of the seismic forces that come into play. And it's not like, if you live in a non-seismic zone, you have to know it doesn't really exist. Non-seismic. Every zone has some level of seismicity, and the code is asking us to check for that all the time, right? It just so happens that sometimes it's such a low seismic zone that we're mostly checking for lateral impacts. When you drop a pallet or you push the rack slightly, we have to take that into account. And all of these forces end up in the members, and we determine the capacity of these members one by one. It's very complex. It's like analyzing a building every time we have to analyze just one system. So the manufacturers, just to make it clear to everyone, manufacturers, they know their product. They have spreadsheets that help them calculate it really quickly. And they're really dedicated to their product that they really know. So they can pump out a new design rather quickly and validate it rather quickly as well. But when you're dealing with an old warehouse, like nobody knows where it is anymore. And you can't really rely on the plans, because when we go in and we check the differences between your LARCs, your stamped drawings, and the reality that you have in the warehouse, the beam sizes have been changed. Some of the uprights are changed right there in the middle of a system. So we analyze all of this. And if there's one upright that is weaker than the others, we'll tell you. We'll tell you, well, this one is like, on either side, you can put that much weight because of that upright.
So there's one final question, and all the other questions will be answered directly. So the last question is there an acceptable amount of rust, a way to evaluate it?
Charles?
Yeah, it's an art. So we have, we provide guidelines for our engineers out there who do have to evaluate it. And there's different levels of rust. So we identify like 4 levels. And depending on what type of element is rusted, usually we're talking about the base of the columns, right? So if it's just surface rust, it's a low priority. We say low because when we hand in a report, everything that we saw will be there, so that you don't have to kind of wonder, did he see it? Why is it not rated? No, so we rate everything that we see, basically. So surface rust, no problem. A little bit deeper, you'll see like a spot on the steel, which is actually like size of a baseball. It's not the whole section that's rusted. It's a portion of it. Again, that's really, the onset of rust. So that should raise a flag.
I think we've reached the end of this webinar presentation. I'd like to thank everybody once again for participating and all the questions that have been put forth. Hopefully we've answered them to your satisfaction. If there's anything further, feel free to send us your questions and we will answer them offline and respond as quickly as we can. Again, thank you for your time. Have yourself a great day.